box you are seeing, that is basically a DSP controller. Okay, so that DSP controller is inside another simulator, that we call it as OP8666. So these two OP stands for their Opalati products. So these two OP will talk to each other now through this feedback and control. That's what we are going to see. So this is one of the schematic of one of my master students. So that model we are going to show you. And the important thing is you have to understand, rather than control, how to use these two machines and what are the hardware connections you need to do, what are the software connections you need to do. For that, we have brought up an expert from Opalati. With me, I want to introduce Mr. Shiva Kumar. He is a field application engineer from Opalati working in Bangalore office. So he will be demonstrating more about these machines and how to implement the model at controller using these two. Over to you, Shiva. Yeah, so if I can put both inverter and control in the same simulator, I can call it as a model in loop. I can do that, but that is the simplest way. But purposefully I am doing controller, hardware and loop. I don't want to put both model and control in same simulator. I want to put model in one, controller in one, so that it makes a loop actually, as you know, control hardware in loop, but my controller will be in a different hardware, I will say, and they will communicate. So basically 5707XG and 8666, they will communicate and control the inverter for grid integration.
Yes.
Okay.
Thank you.
Thank you. You can see.
Okay. So hello everyone. So I am Shiva Kumar from Opalati Technologies. So first, for the next 15 to 20 minutes, I'll just go ahead with a short PPT presentation, which explains you about what is exactly a real-time simulation and why do we use Opalati and where are the applications we find useful with this equipment. So I'll go ahead with this PPT for the 15 minutes, and after that we can go ahead for the demo. Okay, so like Opalati, we are the persons who are into developing real-time digital simulators, which is used for rapid control prototyping and hardware in loop based validations. So these are some of the software toolboxes which we have. I'll RT Lab, eMegaSim. So I'll quickly tell you what is what in the upcoming slides. So we speak about real-time simulations. What is exactly a real-time simulation and how real-time simulation is different from a normal offline simulation. So I'll try to address that query. So real-time simulation means it should be fast enough. Fast enough in the sense, whatever time step you give in your simulation, that time step needs to be respected in real time. To put it in other words, if you are giving a stop time of 10 seconds in your simulation, the simulation has to stop in 10 seconds. It should match your wall clock. So that is what real time simulation is all about. The runtime of the simulation should match your wall clock. If it is running for 30 seconds, then in wall clock also it should be showing 30 seconds. So